Right, so we're looking at the modulus argument form of complex number. So first we're going to consider this diagram, okay? So of course we have the real axis as the horizontal and the imaginary axis at the vertical. So we have a point P, which is going to represent some complex number, okay, x plus yi, and we can of course represent P as a vector from the origin, okay? So from the origin, okay, out to the point P, we have the vector OP. We've done vector notation in physics, haven't we? Yeah. Yes? Is that what you're familiar with? Yes? Okay, so we're doing a bit of vector work in the next few lessons. Within the next few lessons, sorry. Right, and if we form a right angle triangle from the point P with the horizontal axis, okay, so we have distance from the origin to that point as x, which will be the real part of our complex number, and the vertical distance, which will be y, which is the imaginary part of your complex number, the distance, okay, to form our right angled triangle. Okay, these are also in your notes. Okay, so the modulus is what we refer to the distance of the vector OP. So you've got some point complex number plotted onto the Argand diagram, and the modulus is going to be the distance between the origin and that point. So in other words, it's going to be the distance of that vector OP. Alright, any suggestions on how I'm going to calculate that distance? Pardon? Pythagoras theorem. Okay, so we've got x squared plus y squared, and we'll take the square root of that. Okay, the argument is the angle the vector OP makes with the positive x-axis. Okay, that's what's called the argument. And how am I going to calculate that? Trig? What? How?
Y squared is going to be your, you can use y squared or x squared.
Why using y and x squares?
Because, like, opposite over.
Basic right angle trick.
Isn't that basic right angle trick?
Yes, but why using y squares and x squares?
Because there's no definition for anything else.
I've got enough Venn diagram to be able to work out the value of theta. Okay, so remember you go to the hypotenuse. That's the opposite, that's the adjacent, so which ratios is O and A? 10, so tan theta equals y on x. Okay, don't need to use x squares and y squares. Alright, so tan theta is y on x, so theta is going to be tan inverse of y over x. Alright, and that is the argument. Okay, is the angle it makes between the vector and the positive x-axis, or the positive real axis, sorry. Alright, so the arg of z, okay, is that. Okay, so we have the principles in the table. So the modulus, okay, so we notate with the absolute value symbol, okay, for the modulus of the complex number z, okay, is another way we can notate that is r, which is the distance of using Pythagoras theorem when you know the z is x and x plus yi, and we use that formula there. Okay, the argument of z is equal to theta, which is tan inverse of y over x. Negative pi is less than theta, which is less than or equal to pi. So, 180, which is less than theta, which is less than or equal to 180 degrees. Okay? So pi is 180 degrees. Alright, so we will touch more on that when we go through it in mathematics, which will be soon. Okay, so what you need to know is that your pi is 180 degrees. Okay, so the pi in radian measure is the same as 180 degrees in degrees measure. Okay, and to represent a complex number in what's called polar form or in modulus argument form. Okay, so once we find the value for r and theta, we substitute that into this formula here. So z equals r outside of cos theta plus I sine theta. Okay, and instead of writing cos theta plus I sine theta, the shorthand we can write is cis, C-I-S, which means cos theta plus I sine theta. Okay, and you'll see that a lot with your questions coming up. Right, any questions on that? Right, so let's apply it. Express the following in modulus argument form. So, A, z is 1 plus 2i. Okay, so the modulus is the absolute value of z. That's the notation for the modulus. Is the square root of x squared plus y squared, where x and y are your real and imaginary part of the complex number. So it'll be 1 squared plus 2 squared, which is square root of 5. Okay, the argument. So argument of z is tan inverse of y over x. So the imaginary part over your real part of 2 over 1. Okay, not the best example I could have started with because it doesn't work out nicely. Anyway, that's how we work it out. So, z is r cis theta. So r is what we calculated as the modulus, and theta is the argument. Okay, so equals root 5 cos of tan inverse of 2. I'm writing it like this because I don't have the exact value of it, plus I sine of tan inverse of 2. Okay, and that's why we use the cis notation, so we don't have to write cos theta plus I sine theta. We can write that as cis theta. Okay, so cis theta is cos theta plus I sine theta. Okay. Right, B. -1 plus I root 3. Okay, so we need to represent that in modulus argument form. So, modulus x squared, the square root of x squared plus y squared. Okay, so x is -1, y is root 3. Square root of -1 squared plus root 3 all squared. Which simplifies to 2. Yep. And argument is tan inverse of y over x. So root 3 over -1. Okay, when you're calculating the argument, you need to consider your quadrant and you need to consider your sign. Okay, so the complex number -1 plus root 3i is in which quadrant? That complex number, which quadrant? -1 plus root 3 is in the second quadrant. Come on, guys. Or student, take calculus. Okay, so remember that. It's going to come up a lot. So, it is an angle in the second quadrant. Okay, so the argument is the angle from the positive x-axis. Okay, what is tan inverse of root 3? Sorry? Tan of what angle makes root 3?
30.
1 on root 3, 1 root 3. Okay, need to remember that. So the basic angle is that. Okay, so our angle is going to be 90, okay, plus the result from the basic angle.
150.
Okay,
Negative 150?
so,
Is it negative 150?
I see what you're saying, without the negative sign.
Why not? Is it interesting?
Because remember when we found the basic angle, which was 100 in the second quadrant, it's 180 take away the basic angle. Yep, so that's what we're going to do. Now, we need to, unfortunately, the timing has not allowed to do radian measure, okay, for your angle. But we'll just try and fill in the gaps where we can. Remember that pi is 180 degrees. Okay, so if I do 1 degree, it's going to be pi over 180. Use my unitary method. And if I want 60 degrees, it's going to be 60 times pi over 180. Okay, so what's 60 over 180? 1 over 3. So 60 degrees is going to be pi on 3 radian. Okay, so we're just introducing that to you guys. So theta is going to be when we're finding an angle in the second quadrant, it's going to be 180 degrees, take away the basic angle. Going back to your mathematics work. So 180 degrees is pi in radian measure, take away pi over 3. Okay, which is the basic angle. Alright, we treat pi as a variable, so it'll be 3 pi on 3, take away pi on 3, which is 2 pi on 3. So 2 times 180 over 3. So 180 divided by 3 is 60. Okay, 2 times 60 is 120 degrees. Okay, so we'll get this filled in when we get further opportunity. Right, so did that make sense, what you were doing? Right, so that means our z is 2, our argument is 2 pi on 3, okay? That means our complex number represented in modulus argument 4 form is z equals 2 cis of 2 pi on 3 for the angle in the second quadrant. Okay, and remember cis of 2 pi on 3 is cos 2 pi on 3 plus I sine of 2 pi on 3. Alright. C, negative 1, take away I. Okay, so we need to represent this in modulus argument form. Right, so we do the modulus. We can calculate the modulus, square root of 2. And the argument of z is going to be tan inverse of negative 1 over negative 1. Okay, and I suggest you consider where the point is in your quadrant to work out your size of your angle. Okay, so it is tan inverse of 1. Tan of what angle makes 1? 45 degrees. Okay, and in radian measure, it is pi on 4. Okay, because 45 degrees is half of 90 degrees, correct? Okay, and 90 degrees is half of 180 degrees. Okay, so 180 degrees is pi, half of 180 is pi on 2, and then half that again is pi on 4. Okay, so let's look at your quadrant. So the complex number of -1 take away I is in which quadrant? Third. -1 take away I. Okay, and of course we are in the correct quadrant. Not really relevant. I mean, there's other ways we can work it out, but if we just consider where the point is, okay, we can ignore the sign. Alright, and we can work on that. So, how do we represent an angle in the third quadrant using the basic angle? 180 plus. So remember, basic angle, 180 take away for the second, 180 plus for the third, and 360 take away for the fourth quadrant. Okay, so theta is going to be 180, which is pi. Okay, if you're getting confused about your pi's converting from radians to degrees, you can just work on degrees for now until we get the better understanding of radian measure. Alright, and I'll keep working on that until, probably should have done a lesson on that first. Anyway. Alright, so pi plus pi on 4, which is 4 pi on 4 plus pi on 4, so 5 pi on 4. But we have a problem. Because the argument must be between negative theta and, negative pi and pi. Okay, so our answer is greater than pi, isn't it? Okay, so how am I going to get that back into the correct domain? 180. 360. Okay, so it's outside the domain. Okay, so we need to go 5 pi on 4, take away the 360 degrees to get it back into the domain. What's 360 degrees in radian measure? 2 pi. Okay. So we've got 5 pi on 4, take away 8 pi on 4. Okay, so setting the same denominators. Okay, which is -3 pi on 4. Okay, and that's certainly between negative pi and pi. So Z is going to be root 2 cis of -3 pi on 4. Okay, if we're getting this? Yep. And let's try one more. Root 3 take away I. Okay, modulus argument form. Okay, so the modulus square root of root 3 squared plus -1 squared, which is 2. And the argument is tan inverse of the imaginary part, -1, over the real part. Okay, so we can ignore the sign if we consider where the complex point is. But before we go there, what's the basic angle? 30 degrees. How do you know how to represent that in radian measure? Yeah. Okay, because 30 degrees is a third of 90 degrees, isn't it? Okay, so a third times pi on 2, because pi on 2 is half of 180, so we have 6 on the denominator. So 30 degrees is equivalent to pi on 6 in radian measure. Alright, let's consider the quadrant so that we can write the correct location, because remember, the argument is the angle it makes with the positive x-axis. Because root 3 take away I is in the fourth quadrant. There somewhere, so we need to go the whole angle. Okay, so how do I represent an angle in the fourth quadrant? 360 take away. Remember, basic angle, 180 take away, 180 plus 360 take away, your basic angle. Okay, so theta is going to be 2 pi take away pi on 6. Okay, so 2 pi we can represent as 12 pi on 6, take away pi on 6. Alright, which is 11 pi on 6. And again, we're outside the domain of negative pi and pi. So if that happens, you need to take away your revolution of 2 pi to get it back into that domain. Alright, so 2 pi we can represent as 12 pi over 6. So 11 pi take away 6, take away 12 pi on 6 is negative pi on 6. Okay, and that's certainly between negative pi and pi. So Z is going to be the modulus, which is 2 cis of negative pi on 6. Question? Right. Now we have two numbers in modulus argument form. We now need to convert them back to Cartesian or complex number form, so the x plus yi. So 2 cis of 2 pi on 3. Enough space for it? Nope. Right, so this is E. Okay, so 2 cis of 2 pi on 3. Okay, any suggestions on how I'm going to represent that back into complex, the complex number form? Okay. Expand. 2 cos of 2 pi on 3 plus I sine of 2 pi on 3. Alright, so remember pi is 180 degrees. Okay, so pi on 3, so 180 divided by 3 is 60. And then we need to double it. Okay, so 2 pi on 3 is 2 times 180 over 3, which is 120 degrees. Okay, it's an angle in the what quadrant? Second. Okay, so remember we measure angles anti-clockwise from the x-axis. All students take calculus, so sine is positive in the second quadrant. Okay, so what's the basic angle? 120, yep, so basic angle between 0 and 90. 60, yep. So the basic angle in the second quadrant is going to be 180, take away what value that we get, 120. Okay, so the basic angle is going to be 60 degrees. Okay, now sine is positive only in the second quadrant. So 2 lots of cos of 60 plus I sine of 60 degrees. So we'll just go back to what we're used to. Alright, what's cos of 60?
1 over 2.
Okay, 1 over 2, but because sine is only positive in that second quadrant, means cos is going to be negative half in the second quadrant. Yep. Alright, sine is positive. Okay, sine of 60 is root 3 over 2 times I. Okay, and then expand it out. And nicely it cancels for us. So it's going to be negative 1 plus root 3i. And that is the angle in the second quadrant, isn't it? Point in the second quadrant. Okay, so that's one way you can quickly check your answer. F. Root 3 cis of negative pi on 4. Okay, so root 3 cos of negative pi on 4 plus I sine of negative pi on 4. Okay, so negative pi on 4 is equal to negative 180 on 4, which is negative 45 degrees. Okay, going back to our degrees measure to help us out. Okay, and negative 45 degrees is going backwards that way. Alright? So it's the equivalent of 315 degrees, isn't it? Going around anti-clockwise. Okay, so we've got an angle in the fourth quadrant. Okay, so what's the basic angle? Yep, so 360 take away the basic angle would give you that result. So the basic angle is 45 degrees. Okay, all students take calculus. So cos is positive in the fourth quadrant and sine is negative. Okay, going back to the question, it's going to be root 3 cos of 45 plus I sine of 45. Have I read it before? Technicality, I guess.
Yeah.
When I say cos and sine, we probably should be putting a negative sign here. Okay, because we know that sine is negative in the fourth quadrant. So over here I should have put a negative up here. Okay, because cos is negative in the second quadrant. Yep. Okay, so didn't change my answer at the end, but I probably should have written that to there. Otherwise, I'm actually representing the angle in the first quadrant. Okay, that's not correct. But cos of 45 is 1 on root 2 and sine of 45. Okay, don't forget that's I, so you can't just say 1 over root 2, take away 1 over root 2, because you've got real and imaginary part. Okay, so equals root 3 on root 2, take away root 3 on root 2i. And I probably should represent that in with the rational denominator. Okay, so multiply top and bottom by root 2. Okay, so root 6 on 2. Take away root 6 on 2i. Okay, which is an angle in the fourth quadrant, isn't it? Because you've got the positive real part and an imaginary negative part, which fits into the fourth quadrant. Okay, any questions?